Hello everyone, it's the guy who tutors, and we're going to be taking a look at quantum numbers today. So let's get first a refresher on our quantum numbers. So we have four different types of quantum numbers, and each of them signifies a different thing about the electron that we're talking about, and thus we can identify basically which element we're talking about just by having these sets of numbers. So let's start with n. What is n? N is the energy level. Energy level. So we can use this n to say, okay, this is in the second energy level, this is in the sixth energy level, and thus we can figure out what period it's in on the periodic table. Or, well, unless it's a D or an F, but we'll talk about that when we get to there. And if you've already had a solid introduction on quantum numbers, then you know that different orbitals fill at different times. So then let's look at L. So L is the type of orbital. So 0 implies it's an S-shaped orbital. So, or it's the S type of orbital. So it's that the first two columns of the periodic table. That's the S block of elements. 1 implies P, which consists of the far 6 columns of the periodic table. The D block are the 10 in between that on the standard periodic table, or the transition metals. And the F blocks are the lanthanides and the actinides, which are usually down below the periodic table, or if you have an extended one, and it shows what it would actually look like, it's between the S block and the D block elements. Common misconception, lutetium and lawrencium are not lanthanides or actinides. They are transition metals. So let's look at these problems. You're going to probably see this at some point during your chemistry journey, your quest of awesome proportions. You're going to have to determine whether or not a certain set of orbitals is possible. So let's look at this first one here. So we have n equals 2. So that implies that it's in the second energy level. So it's going to be either 2s or 2p, based on what the periodic table looks like. L equals 0. That means that it's going to be the s orbital. So we know this is going to be 2s. If it's real, it's a 2s element and will either be what is it? Lithium or beryllium. So, and then we have ML. This should actually be M subscript L, but I can't do subscripts on this web whiteboard. And same for MS. That should be M subscript S. M subscript L is -1. So this particular quantum number implies the placement of an element or of an electron in a given orbital. So for when it's 0, when the orbital is 0, it's the s orbital, we can only have it equals 0, because that means that it's essentially one single orbital, one single part of this s orbital that's filled. And a single orbital can have 2 electrons. So if you're looking at the p orbital, there are 6 groups, or 6 sets of electrons. So therefore it can alternate between the -1 set of 2 electrons, because each one has 2, the 0 set of 2 electrons, and these are just arbitrary numbers, it just helps us identify placement, and the +1 set of numbers. The s orbital can't have that. The s orbital can only have 0 because there are only 2 electrons in an s orbital. Therefore, this is let's use this. Not possible because M subscript L cannot equal -1. Alright, 1 down and we have 2 to go. So let's look at this one now. And remember that this is not testing whether or not this orbital exists. It's asking whether it can exist. So we'll get into a little bit of that with this next one here. So n equals 6, that's the 6th energy level. L equals 3, that means it's an F block orbital. So this is a 6f. Now, a standard periodic table only goes up to 5f because it's n minus 2 in that particular period, and it's energy level 7 minus 2, 5f. So that implies that we'd have to have an entirely new period. What? What? Why? We actually haven't discovered any elements past that point yet. Past element Unu Noctium, because it gets just too unstable beyond element 118. So we don't have this 6f orbital yet. That isn't to say that it can't exist. It very much can exist at some point if we really advance our technology. It just doesn't yet. So the other two, are correct. This implies that it's this particular set, which is fine. It has to be between 2 and negative 2, and it is. And the spin number is negative 1/2. As long as it's either positive or negative 1/2, it's going to be correct. If it's anything else, then it's wrong. So possible, but not yet achieved. Let's look at the last one here. And we have a lot of zeros here. So n equals 1, that's energy level 1. So we already know it's going to be either hydrogen or helium. L equals 0, that means that it's in the S energy level. So this is 1s. They both are. It's not like we can have anything else in that energy level. ML, or so this particular one, we know that this is it's the only one that can exist because there are only 2 electrons. And then the spin number is 0, and as I mentioned a second ago, it can only be positive 1/2 or negative 1/2. Again, arbitrary numbers, but that is impossible. So we can say that this one is not possible because spin number cannot equal 0. And so I hope you guys now have a better understanding of quantum numbers and how to tell whether a given element is actually going to, or how, when a given set of quantum numbers is actually real or not. You're kind of like a little bit like a sleuth, I guess, if you want to think of it that way. Remember, guys, to like, subscribe, comment, do all that wonderful stuff. And when in doubt, divide by moles. That's not what it actually is, but remember, solve for moles is a great tip, I'm telling you guys. Anyway, thanks, and Guy Who Tutors is out.